Good afternoon. This is the June 16th update on 92L here in the southern and central Gulf of Mexico. I mean, it's kind of all over the Gulf of Mexico now. But anyway, as always, please refer to the National Hurricane Center and National Weather Service office for your area for all official information regarding your area. I'm just kind of talking about the big picture here. This is not something that pertains to each locale that is on the northern Gulf Coast. So stay tuned to the National Weather Service in Lake Charles, New Orleans, Biloxi, Mobile, and Houston, Galveston. So here we have 92L, our little vorticity maximum that we discussed yesterday, crashed into Mexico and completely died. So that essentially takes a lobe off of this gyre that is now moving northward. There's more stuff off screen here in the Eastern Pacific, but we're not going to be talking about that because it's kind of separated from this area of vorticity now. You have a lot of southerly flow on this side of the system that is turning gradually east. This is in a generally favorable area for increased vorticity, along with the already pretty obvious vorticity that you're seeing here with flow coming out of the northeast on this side and then flow transitioning to out of the north and then gradually coming back up to the south. So this is a general area of vorticity that you're seeing here. A couple of focal points of vorticity under these thunderstorm complexes that have developed, but nothing very organized. This is still a complete mess. And if there's any changes that we've seen, if we look at water vapor imagery, you can see that the flow over this trough has changed a little bit. This trough is a little bit more negatively tilted now, and that is actually not what was modeled by the GFS. So we're going to get into that in a sec. We talked about this yesterday, about the diffluent flow, divergent flow over the system that is allowing for convection to sprout. And this kind of, what this does, it creates a positive feedback loop between the convection and the divergent flow, because the divergent flow allows for convection to continue. So you have this very intense complex of thunderstorms right here that is pushing flow more into this trough, because this trough is oriented, I think, right around here. And essentially what this is doing is distorting the flow near the trough, and it will eventually be able to expand all the way out to the west because of the positive feedback loop of more divergence equals stronger thunderstorms, and stronger thunderstorms equals more outflow, which equals more divergence. And that will eventually be able to push this trough completely out and create an area of lighter shear over the general convective mass that this will have. Now, as far as vorticity goes, since we're dealing with such a large area of vorticity here, it'll take a long time to consolidate. There are focal points, as I said earlier, but it will depend on how quickly this convection can kind of consolidate and maybe push out this shear, because this shear is bringing in relatively dry air. The flow is still predominantly southwesterly, and even though there are kinks in the flow, overall, this is going to be westerly flow or southwesterly flow that is over the system. And so even if this is able to consolidate, say it comes up here, well, there's the circulation center that will be right here, and then you'll probably have a system that looks somewhat like this in the best case scenario for the system. And you really won't have a southwestern side. This is going to look very sloppy. There's going to be, as you can see, there's a lot of moisture on the eastern side of this, and this is all just going to kind of be brought up. This is not going to get wrapped around into the circulation. This is not possible for a system of this magnitude because it's very weak, and even if the vorticity strengthens, it will not have enough time to consolidate. This is huge, and a large fetch of moisture is associated with this, and it will not be able to consolidate in the time that it has been given or the conditions that it is in, even if there's a lighter shear pocket that is able to develop a lower level circulation under. So we will still be dealing with a mess but maybe a little more organized of a mess as it comes up northward. Now, the GFS, the reason I said what I said about how the GFS was modeling it, if we look at the GFS right now, you have a pretty much vertical trough here. You have a trough that is centered over the Gulf of Mexico right now, and there's a little bit of dry air, and the flow is predominantly westerly. Now, and there's no flow that's being pushed into the system or into the trough. And that does not change in this entire GFS run. There's maybe a little bit of flow that's being pushed into it, but it's still in a pretty predominantly rough shear environment. There's a little bit of light shear in the Gulf, but overall the shear is pretty bad over the system, so it's not able to consolidate. You can see that on the precipitation forecast. You have convection that is well removed from what eventually becomes the low-level center, and that remains the case as it sits or moves in and then sits over the deep south. Now, the German model has something a little different where it is more consolidated and maybe gets to 1,000 millibars and is able to deepen just a little bit before making landfall. And not, I mean, this is again a early season system that has a large fetch of moisture coming up from the south, and then you have the generally consolidated area of stronger convection, but nothing too intense. And as far as winds go, this is not going to be an issue. We talked about that yesterday. It absolutely will not be an issue. Maybe you'll have occasional gusts to 60 miles an hour located on the eastern side of this system because the winds on these east-weighted systems are drastically stronger on the east side than on the west side. Like, as this comes up, you'll probably have winds on the west side that are anywhere from like 20 to 30 miles an hour. And on the east side, depending on how strong this gets and how organized this is able to become, anywhere from 40 to 60 miles per hour. And so it's essentially just rough weather. And the likelihood of wind damage is pretty low, if I'm being honest. So, but that's not what we're concerned about here. What we are concerned about is this. We have a new rainfall forecast from the WPC. This is a 7-day forecast from the WPC. This is the official forecast, and you can see that the rain swath has moved a little bit to the east on this forecast, but it is more intense, and this is likely due to the models slowing this as it comes to the coast, because it'll start by moving slowly towards the coast, and then it really slows down and kind of just lingers here over the deep south. Now, this is not exactly what the track is going to be. Obviously, there will be changes, and we're still waiting for a lower level center to develop, actually. So, recon will help tomorrow, but right now we still are pretty much taking a shot in the dark as to where this exactly will make landfall. But again, this is such a broad system that it doesn't really matter too much where this makes landfall, because regardless of where exactly it makes landfall, all the stuff on the eastern side will be sitting over the same area for a while. And so you can see this rain swath is now including rain totals over 10 inches and a larger swath of 7+ inches and 5+ inches now over the deep south. And this could, get translated anywhere 200 miles this way or that way, or east or west. And that does make all the difference, because yesterday, go back here, southwest Louisiana and south central Louisiana, and quite frankly, just the southern third of Louisiana yesterday got racked with a lot of rain in the afternoon and evening hours. And this is going to be coming up shortly after that. And you really don't want to see rainfall totals like we're seeing in this WPC forecast over this area. So if you're in southwest Louisiana or in southern Louisiana, even on the deep, all the way on the coast, pretty much from the eastern Florida Panhandle all the way even into just to the southwest of Houston, you do need to be watching this for flash flooding reasons and maybe a bit of coastal flooding because of the orientation of the system. You have a lot of southerly flow that will be pushing a lot of water. Even though the flow is largely weak, it's still pushing a lot of water because of how large this fetch of wind is. And so you may get a storm surge that is a little higher than what a normal tropical storm would generate. So all these are dangers that will be presented. This is pretty standard for a June tropical cyclone. It's just unfortunate that it is coming almost immediately after another bunch of flash flood events that have already occurred in this part of the country here, and really don't want to see that. So please do stay safe if you're in Southwest Louisiana, and please do pay attention to your local weather office and your local authorities for all the latest information regarding your area. That's all I got for now. Thanks for watching.